Okay, so Leetcode practice question. In this video, there are two goals. The first goal is to see how to solve this problem, of course. So first of all, we find the solution and then we do some coding work. And the second goal is to see how we should behave in a real interview. So let's get started. So in a real interview, remember the first step is always first fully understand the problem, what the problem is asking you to do, and also if there's any question, please bring up the question to the interviewer. Don't be shy, and at the same time, think about some edge cases. Let's take a look at the question. Course schedule 2. There are a total number of n courses you have to take labeled from 0 to n-1. Some courses may have prerequisites. For example, if prerequisites I is AI/BI, this means you must take the course BI before the course AI. So given the total number of courses, num courses, and the list of the prerequisite pairs, return ordering of courses you should take to finish all courses. So if there are many valid answers, you can return any of them. If it is impossible to finish all the courses, return an empty array. So let's take a look at example 1. We have two courses, 0 and 1. It says that the prerequisite is we need to take 0 before take 1, so output is 0 to 1. And example 2, we have 4 courses and 0 is required before taking 1, 2. So it's like 0 and then take 1, 2 and then take 3. Okay, I think it makes sense. Let's see some constraints. It says that the num courses is between 1 to 2000. Okay, and the prerequisites length is between 0 to num courses times num courses minus 1. And the prerequisites I dot length is equal to 2. And all the pairs of the prerequisites are distinct. Sure. So there won't be any, and also there won't be any prerequisites that have the same, like course I requires to take course I before that. So it doesn't make sense though. Taking a look at that, I don't see any very obvious edge cases. So let's see how to solve this problem in general. So this is a topology sorting problem. Topology sorting problem. So essentially you have a topology graph, the dependence graph, and you want to get the topology sorting for all the nodes within the topology graph. So essentially for the topology graph, you have the in degree. So in degree for each of the node. And to get the topology sorting, you will have a queue. So first of all, you will add the nodes with in degree as 0 into the queue. And when you pop the node from the queue, you're going to find all of its edges, its neighbor nodes, and minus the corresponding in degree for those nodes. If any of the nodes have in degree as 0, then you keep adding into the queue. So that's essentially how to solve the problem. So the runtime to build, okay, so the runtime, we need to at least go through all the edges. And yeah, so first of all, we need to get the in degree for each of the node. So for that part, we need to go through all the edges. And for the next part, we need to do topology sorting. So topology sorting is more about the queue. So for the queue, it is also based on the number of the edges when we get neighbors. Okay, so I think the runtime is going to be O let's say there are n nodes and e edges. So the runtime in total is going to be on plus e. So having said that, let's go to the next part, which is about coding. For coding, don't be too slow first, and also take care about the correctness and the readability of the code. So let's take a look. Give it a try for the coding. We should say, okay, so first of all, we will need to have the integrate. So I'm thinking. So first of all, let's see if we should have the integrate or just or we should build the graph. Or maybe we could do two things at the same time. So first of all, we define the integrate new int of the num courses, and also we will need to define the graph. So the graph would be a map from integer to a set of the nodes with integer. So this is a graph. New hash map. And then we are going to go through every prerequisite pair. Prerequisites. Okay. So it is for the prerequisite, it is something like from node is going to be prerequisite 1 and 2 is prerequisite 0. Yeah, so we are going to have integrate 2 as plus plus because there is a edge from pointing to the two nodes, and also at the same time we need to have the graph, update the graph. So we will have graph dot okay, so if the graph doesn't have the key as from, then we will have graph dot put from a new hash set, then graph dot get from dot add the 2. So at this point we have fully initialized the integrate array and also the graph. So the next part is about topology sorting. So for topology sorting, we need a queue. Let's say it is a prerequisite. So let's say it is an integer. Queue as new. This is a new. Let's use linked list as a underlying implementation. Yes. So if okay. So well, the queue is not empty. Then we are going to do topology sorting on top of it. So at the very beginning, we should initialize a queue with the nodes that has 0 as the integrate. So int I is equal to 0, I is smaller than n, plus plus I. So if the integrate I is equal to 0, then we are going to have the node added into the queue at the very beginning. So while queue is not empty, we will have int courses as, so I think we should actually have the course other define, which is the result finally we potentially need to return. So this is the num courses, so and course idx is equal to 0. Alright, so we first of all pop the so first of all we need to pop the course. Okay, so int it is course id, just a course, it is q dot pull the course. So you pull the course that is in the queue, so any course in the queue has int degree as 0, and we are going to go through all of its neighbors. Int neighbor, or maybe just next, as graph dot get or default course new hash 7. So we go through everything within the next course, and we are going to do int degree next to be the minus minus, because essentially we have finished the prerequisite course for the next course. So if the int degree next is equal to 0, that means we can actually take it. So we are going to say q dot add the next. And after we pull a course from the queue, we should actually add the course idx plus plus as a course. So that's pretty much it about the stuff. And finally, if the course idx is not if it is not equal to num courses, then we are going to return an empty array. So an empty array, what does it mean? If it is impossible to finish all the answer, we just return empty array. So does the empty array mean something like this? I guess so. Otherwise, we will return course other as a final result. Okay, so we are pretty much done with coding. Let's do some testing at this time. So for testing, we need to go through a simple example explaining how this piece of code is going to operate on that example, and at the same time we do some sanity check about the logic, fix some bugs, etc. So let's say we have 2 courses. Let's say for this one we have 4 courses, and we have the prerequisites something like this. First of all, we have int degree as 0, 0, 0, and 0, and then we have the graph something like empty. And in this for loop, we are going to get each of the prerequisite plus the int degree for the 2. So now we have this as 1, this as 1. So 3 has a, this is 1, and 2 has a, okay, 3 has another, so this is 2. So this is the int degree, and also at the same time we also have the map. So 0 to 1, 2, and 1 to 3, and 2 to 3. So after the initialization about the int degree of the map, it is time to do sorting. So first of all, the queue would contain 0, because the int degree for 0 is 0. So course order as a empty stuff, which which is 0, 0, and 0, and 0. So if int index as course index is 0 as well, course idx as 0 as well. So you see that course is equal. So first of all, we pop 0 from it, and we are going to set the first one as 0, course index as 1, and we go through all of its neighbors. So the neighbor of 0 are 1, 2. The next courses to take are 1, 2. So we are going to minus the integrate for next, which is 1 to be 0. So it is 0, so we are going to add it into the queue. Then this one is 0, we are going to add it into the queue as well. And next time, when we pop the 1 here, so we are going to pop 1 from it, and course index is 2, and then we see that the next thing for 1 is 3, so we are going to minus the integrate for 3 as 1 at this moment. And next time we have this as 2 and course idx as 3, and then we have this integrate as 0 and we update it as 3. So it is 0, 1, 2, 3. So this is also a valid answer as well. So the question says if there are multiple answers, we can return any of them. So I think it should be good. Let's give it a try. So this one, new int. Some typo here. Oh. So this is n, which is, it should be num courses actually. Alright, so after fixing the typo, I think we are good. Let's give it a submission. Okay, so it seems like everything works well. So that's it for this coding question. And if you have any question about the solution or about the puzzle, whatever, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.